Alright, my friends, are you ready to build that convolutional neural network? We have a long but yet very exciting journey ahead of us. Let's do this, let's kick this off. Alright, so we're going to start with the very essential step, importing the libraries, which will only consist of importing TensorFlow and actually the preprocessing module by the Keras library. So let's do this first quickly and efficiently in a new code cell. So actually, you know how to import TensorFlow. We start with the import command. Then we specify the name of the library, TensorFlow, and we add the shortcut TF, just like before with the ANN. Then I would like to import something else which will allow us to do the image preprocessing in part 1, and which is the image submodule of the preprocessing module of the Keras library. And therefore here we're going to start from, well, the Keras library, from which we're going to get access to the preprocessing module, from which we're going to import the image submodule. And the reason why we want to import this is because we want to import a specific class, which is the image data generator. And I will explain very quickly what this is about, but this is absolutely compulsory in part 1 data preprocessing, when preprocessing your images. So let's import it. Here we just need to add import and then image data generator. Okay, good. I will explain very soon what this is about and how we will use it. All right? And then, this other thing that I like doing, just to show you that indeed we're working with TensorFlow 2.0, I just want to print the version of TensorFlow we're using right now. And remember, to do this, we need to call TensorFlow first, and then after a dot, a double underscore, and then version, and double underscore again. And this will, print in the output the version of TensorFlow we're using. This is just to make sure we're working with TensorFlow 2.0. However, depending on when you run this code, after I record this tutorial, you might have a different version, but you will definitely get a TensorFlow 2 version, okay? All right, so here I just executed the first cell, importing TensorFlow and the image preprocessing module like Keras, and now let's run this to indeed reassure ourselves that we are working with TensorFlow 2.0, which is so much better than TensorFlow 1. All right, good. So now we can move on to part 1, data preprocessing, which will be done in 2 steps. First, preprocessing the training set, and second, preprocessing the test set. So let's start with the training set, and let's create a new code cell. And now let me explain how we're going to do this. All right, so how are we going to preprocess our images? Well, we're actually going to do multiple things. The first thing we'll do is we will apply some transformations on all the images of the training set. The images of the training set only. We won't apply these same transformations on the test set. The reason why we want to apply some transformations on the images of the training set is for only one purpose. It is to avoid overfitting. Indeed, if we don't apply these transformations, well, when training our CNN on the training set, we will get a huge difference between the accuracy on the training set and the one on the test set, on the evaluation set. Actually, we will get very high accuracies on the training set, close to 98%, and much lower accuracies on the test set. And that is called overfitting, and that's something we absolutely need to avoid anyway, whether you're working on a classic data set or working for computer vision. And for computer vision, well, the way to avoid overfitting is, as I said, to apply transformations. So that was the why, and now let me explain the what. What are these transformations? And then I will proceed in the end to the how we're going to implement that. So the what are these transformations is, well, some simple geometrical transformations or some zooms or some rotations on your images. So basically, we're going to apply some geometrical transformations like transvections to shift some of the pixels. Then we're going to rotate a bit the images. We're going to do some horizontal flips. We're going to do some zoom in and zoom out. Well, we're going to apply a series of transformations so as to modify the images and get them, as we say, augmented. In fact, the technical term of what we're going to do now, with all these transformations, is called image augmentation, which consists basically of transforming your images of the training set so that your CNN model doesn't overlearn, is not overtrained on the existing images, because by applying these transformations, we will get new images, which is the reason why we call this image augmentation. We basically augment the variety, the diversity of the training set images. All right, so that is the what, and now we're going to proceed to the how, and to proceed to the how, I'm going to take you to the Keras API, because you have to see it. Just like what we did with scikit-learn, I'm going to show you and guide you through the Keras API to find the exact tool we're going to use for this. So let's open a new tab here. There we go, and in the search bar, let's enter just Keras. Keras like that, let's press enter, and let's just get the first link. There is only one Keras, and that's of course the deep learning library in Python, developed by François Chollet, by the way, a very talented French data scientist. All right, so let's go now to API docs. And now, my friends, welcome to the Keras API. This is probably my favorite deep learning library. It's absolutely fantastic. And now where we want to go is, of course, to data preprocessing, which includes, of course, three things. Actually, you have to know it. Image data preprocessing, which is what we're about to use right now, but then also time series data preprocessing and also text data preprocessing. You can also do some deep NLP, NLP with deep learning with Keras. But now, of course, we're looking for something in image data preprocessing, and let me show you exactly what that something is. We just need to scroll down. Well, actually, you already know what this is because we already imported the class, but there it is. I'm talking, of course, about the image data generator class, which will indeed generate batches of tensor image data with real-time data augmentation, which is exactly what I've just explained. And I haven't mentioned the batches yet. Well, that's because, we will create different batches of actually 32 images, and these images will either be the original ones or, the augmented ones, the transformed ones, after we apply the transformations. And speaking of applying these transformations, well, we're going to do that exactly with this image data generator class, for which we'll find all the arguments here, and most of them correspond to different transformations. I can already tell you that we will use the zoom range, which consists of zooming in or zooming out on the images, but also we'll use the horizontal flip, which consists of flipping the images horizontally. And then we will also use this one, the shear range, which is some kind of transvection. You can check it online, but no need to understand this in all the details. Just know that it's a geometrical transformation, and if you want to go further, that it's actually some kind of transvection. But there we go. These are the three transformations we'll use: the shear range, the zoom range, and the horizontal flip. And now I'm sure some of you are asking, why do we use these transformations? Well, I'll be honest with you. The reason I'm using them is because I simply took, the code snippet example from Keras, which is right below exactly here. This is the code snippet example using the image data generator class. And as you can see, we use a shearing transformation, a zoom transformation, and a horizontal flip transformation. And we're just going to do the same, but of course, feel free to try some other transformations. Who knows, maybe you'll get better accuracy in the end, okay? But let's just trust this, and actually I trust this because of course I tried it on our future CNN, which we're about to build, and you're going to see that the results in the end will be absolutely amazing. Okay, so let's just take this code snippet to, actually get the tool that will apply these transformations. Then of course we'll have to connect the tool to our training set. So back into our implementation, well, let's paste that right here. And this, as you can see, creates an object, which we call train data gen, of the image data generator class. So train data gen is an instance of that image data generator class, and which represents, of course, the tool that will apply all the transformations on the images of the training set. And there is one I haven't mentioned. I mentioned and explained these three ones, which are the transformations, but we also notice this one, rescale equals 1 divided by 255. Can you guess what this is about? We already saw this many times on our classic data sets. Well, this is of course about feature scaling. This will apply feature scaling to each and every single one of your pixels by dividing their value by 255. Because remember that each pixel takes a value between 0 and 255. So by dividing all of them by 255, we indeed get all the pixel values between 0 and 1, which is just like a normalization. And once again, feature scaling is absolutely compulsory for neural networks, when training neural networks. All right, so basically this is feature scaling, and these are the transformations that will perform image augmentation on the images of the training set. And this, I remind, is in order to prevent overfitting in the end. You can try actually, the future training we'll have without these, and you will see what I mean by overfitting. All right, good. So that's not it. That's not it, for the training set preprocessing. We need to, of course, now connect that train data gen object to our training set, to our training set images. So far, this is just the object. And so the way we're going to do this is we will, of course, go back to our Keras API, because indeed the way to do this is just to take this next code here that will actually import the training set by accessing it from, our directory, and at the same time creating these batches and resizing the images, in case we need to resize them in order to reduce the computations of the machine, to make it less compute intensive, which is what we will do, because we will see that with a lower size, we will still get amazing results in the end. So let's get this, and once again, I will explain all this code, and mostly we will have to change it the right way so that we can adapt it indeed to our situation. So let's take it step by step. This is actually the name you want to give to your training set, which you are importing in the notebook. And let's just keep the usual names. We're going to call that training underscore set, just like before. Then we take indeed our train data gen object, that instance of the image data generator class. And from this object, we're going to call a method of this class, right? Because this class, as every class, contains methods, and one of them is this flow from directory, which will just simply, connect this image augmentation tool to the images of your training set. All right, then let's have a look at the different parameters. So the first one here is actually the path leading to your training set. And so, of course, we have to change this because we have a different path to our data set. So this is the whole folder which I've shared with you at the beginning of this section. And this is also the root folder. This is the base of the folder, the beginning of the path. And so now, in order to access the training set, well, we first need to specify that we want to go into this dataset folder and then into this training set folder. And that's exactly the path leading to the training set. And therefore here, in this parameter of the flow from directory function, well, we simply need to replace data here by dataset and then train here by training set. All right, this is the simple path leading to the training set folder, starting from the root of our directory folder. Okay, good. Now next argument, target size. That's indeed the final size of your images when they, will be fed into the convolutional neural network. And actually, I tried with 150 by 150, and that actually made the training very, very long. So I actually wanted to reduce that to, 64 by 64, and that's totally fine. This will make the training much faster, and still we will have amazing results. You'll see that at the end. Then the batch size is, the size of the batches, meaning how many images we want to have in each batch. And 32 is the classic default value, and we're going to keep that. That will be totally fine. And finally, we have to specify the class mode, which is either binary or categorical. And of course, since now we have a binary outcome, cat or dog, well, we have to choose, of course, class mode equals binary. Okay, perfect. And that closes the preprocessing of the training set. We're done with this first step of data preprocessing, and so now we're going to move on to the next step, preprocessing the test set. And of course, in the spirit of always be as much efficient as we can, well, we're going to go back to our Keras API, and we're just going to take this time, this line of code to, get that same image data generator object to, apply the transformations to the test images. But be careful, we're not going to apply the same transformations here, such as the shearing, the zoom, and the horizontal flip, because of course we don't want to touch the test images, because they're like new images, like when deploying our model in production. And therefore, of course, we have to keep them intact, like the original ones. However, what we have to do to them is indeed to rescale their pixels. And that's the same as before, Remember when we were applying feature scaling to our training set and test set? Well, we used the fit transform method on the training set, but only the transform method on the test set. And that was, of course, to avoid information leakage from the test set. And well, here that's exactly the same. We have to keep the images of the test set intact by not applying any transformation. However, we have to feature scale them because once again, the future predict method of the CNN will have to be applied to the same scaling as the one that was applied on the training set. So you see, this is exactly the same as before, it's just that we are using some different classes, but which are, after all, the same tools. All right, so let's get this and let's put that back into our implementation in a new code cell. So we're going to paste that. We're going to keep the same name for the object. That's totally fine. And then, well, same. We're going to go back to this and we're going to get exactly this, which will actually import the test set images into our notebook. All right, so let's paste that. And now let's do the required change. Actually, please press pause on the video and do the changes yourself. I'm sure you're gonna do this successfully because this is exactly the same as before. All right, so now let's do it together. The first thing I would like to do is just change this name, which is exactly the name of the variable that will contain the test set. And just to be consistent with before, well, let's just call it test set. All right, so test set. Then this is correct. We call our test data gen here, which will only apply feature scaling to the pixels of the test set images. Then we call that same function flow from directory to access the test set from our directory. And here, once again, we need to replace data here by data set and then validation by, remember, now we want to get the path that leads to the test set and therefore that first data set and then test set. All right. So here we just need to replace validation by test set. Good. Then of course we need to have the same target size because basically the predict method has to be called on the exact same format as the one that was used for the images of the training. So here we need to get the same size as in the training set, therefore 64 by 64. And the same batch size. Basically our model will be evaluated on batches of 32 images and of course the same class mode binary. Good. Well, there you go. We're done with data preprocessing. It was very different. It was actually brand new, but we recognize some of the same process steps as what we did before. And so now I'm very excited because we can move on to the exciting part, which is about building the CNN. Yes, we're ready for part 2 now, which we're going to tackle in several steps. And so make sure to get good energy for this. And as soon as that is the case, join me in the next tutorial to smash this time part 2, building the CNN. And until then, enjoy machine learning.